Good morning. Welcome to webinar. Thanks a lot for taking time on your busy day. I am Imran Jagirdar. Next 50 minutes, I am going to brief you quick view and overview on complete mold design solution inside SolidWorks platform. During this webinar, if you have any doubts, kindly note it down. At the end of the session, 10 to 15 minutes, I will clarify the same. Just use chat menu to share your doubts. The prime objective here is to enable mold engineers to do complex plastic mold design in SolidWorks. "3DQuickMold" is a professional plastic mold design solution. It is developed by an engineering team with 15 years in CAD programming and 17 years in plastic mold design industries. This solution is now fully integrated into SolidWorks. Through SolidWorks Command Manager, user can access the commands in various ways or customize their own shortcut keys. New user interface help designer to speed up mold design tasks. "3DQuickMold" follows the industrial practices and use the same workflow in mold shop. It also offers complete solutions. Start with product assembly for core and cavity separation, a layout wizard for placement of the component, orientation of the component, and number of cavities can be defined. Mold base wizard for standard mold base like Fituba, LKM, Hasco, or DME standards, and ejector wizard and cooling wizard, some library wizard, insert wizard for local inserts, electrode wizard, and feed wizard. Mold design engineers spend a big ratio of design time in splitting mold. 3DQuickMold combines the experience of mold makers and the powerful modeling functions of SolidWorks, and results is very fast and direct mold split feature in this system. So we simplified all the patching words or all the loops which we need to close, and whatever data we created, we can reuse the same thing to creation of the inserts or side cores. So I'll just brief you product assembly focused on core and cavity separation based on new SolidWorks multi-body technology. Easily we can create very complex core and cavities. Also supports family and multi-cavity molds. Also allow user to build side cores, sub-insert on the same parts, and also automatically open all the pockets for side cores and sub-insert instantly. So mold is fully associated with the product model, and changes occur in components. Any changes, any modifications in the components, the same time core and cavity also going to updates automatically. So there is a mold. Let's talk about in depth the complete procedure. For example, there is a mold base here. As I told you, there are standard libraries are available like DME, LKM, and Fituba and Hasco standard. And also it's allow you to user to customize their own libraries, and also allow you to any changes in the mold base. Suppose you started with a standard mold base and then changes is required. It's allow user to change the mold base based on their requirements, so that even we can do modify all the complete mold base structure based on our requirement. Just let's have a look the same thing with the 3D CAD interface. So here I'm just in the live demonstration, I'm just going to share there are just two components. There are in the parting environment, there are two approaches here. For surface, for irregular component is surface parting approach. For solid type of components, just solid parting surface approach. So let's have a look here for this component. There's a simple one component here. I'm just showing the approach. So inside SolidWorks itself, we have a draft analysis, undercut analysis, and parting analysis. Draft analysis, by using draft analysis, just by locating the planes, easily we can find out, still is there any in this component, still we need to provide a draft. I just mentioned 3 degree here, so immediately it shows the draft angle, less than this, there is a just 2-degree draft is available here, and then here you can see there are still less than just the 0 degree draft is available here. So it means that in SolidWorks itself we have an option to study this component, maybe if the draft required, and also it's highlight undercut analysis where we can find out just by locating the plane, it shows on positive drafts and negative drafts, and also it shows wherever undercuts are there. Here you can see red color. So these are all, it shows that there is undercuts in this. So basically these are all options are just first study the component. Whereas from here we'll start a tool mold design activity. So let's start a mold design activity for this. I'll just start with shrinkage factor. So any changes required in the component, still it's allow you to change with the CAD platform. So once we start a mold design, so we need to add a shrinkage factor. Material database is available in this. So just change the material. So immediately you can see the shrinkage value also is going to update in this. And also shrinkage can be placed with respect to origin, with respect to centroid, or with respect to coordinate system. For example, I'm just going to use origin, which is already placed in this. Shrinkage will be added to this component. So now I'm going to define a workpiece. A workpiece is nothing but core and cavity block size. Just fine tuning these dimensions. So quickly, some reference planes are created. This is basically it's a core and cavity block size. So now I'm going to search the cavity and core faces. So for that, just I'm going to define, there are some faces here to search the cavity faces. You can see here immediately it's take all the faces belongs to a cavity face, and some more additional faces I'm going to add. Since I know this, there are some undercut in this. So these faces also I'm just going to consider at present as a cavity. So immediately it will segregate with the different colors, like with the green cavity will be a green color, and then core side will be in the red color. So now I'm going to extract the parting surface. So let's search the parting surface. So while searching parting surface, since there is a loops in this component, since there is some openings in this components, so immediately it will list down all the openings, and it is going to create automatically. It's going to close all the surfaces by using shut off surface option. So this option is available already in SolidWorks environment in mold tools. Whereas instead of using that option, the moment you use this option, it's automatically this feature will be part of this. It's going to close everything. So let's create a parting surface by using outer loops here. So I'm just creating a parting surface. So parting surface is created here. So let's take a look. So now you can see parting surface is created. So now I'm going to create a core and cavity for this. These options are very simplified. Just we need to follow our process. So let's create a core and cavity. So immediately core and cavity will be created in the same part file, but we need a separate part files because this is a component file, and we need a core will be a different and cavity will be different. And as we know that there are some side cores are there in this component. So I'm just going to create a side core. So this is the area side core for side core. Let's create a side core for this. So I'm just going to create one sketch on this. So here I'm going to refer this sketch just by using convert entities. So immediately it will converted. So I'm just going to extrude this sketch. So let's use a core option here to create a side core. So just I'm going to use this. And you can see immediately it's converted as a side core. So now you can see there are 3 different multi bodies are created in this part file. So the final option will be I'm just going to save this as an assembly. So let's define this as a cavity, this as a core, and then few more options are there here to maybe it's an insert or side core. Since I have one side core here, I'm just going to define this as a side core. So now you can see there are three different part files will be created as an assembly file, as a sub-assembly file. So explode, here you can view with the explode options. So there are three different files. And we can view the animation part of it. And also it's allow you to save this animation in AVI format. So let's have a look for another component. With that component, I'm going to continue complete mold design. So there's another component. So you can see there is a component here. So this is there is no irregular surfaces in this, but still if you study this component, still there are some openings are there, through openings are there, and also when you run the undercut analysis in this, let's have a look. So I'm just going to define this as a reference plane, and you can see in this component, this is the area it highlights there are some undercuts are there. So I've just studied this component. So as usual, we'll start with extraction for this. So let's start with the shrinkage factor as usual. So metal database is available. Let's define the material. So now we can define workpiece is nothing but core and cavity block size. So I just quickly defined core and cavity block size for this. So here also the procedure will be same. Since this is a solid type of component, we need to close this all the openings. So already I created few sketches to close these openings. So just with the normal procedure, so I'm just going to extrude this feature to close this particular area in the reverse direction. I'll just use up to this surface. So it's closed. Similarly, one more sketch I have here. So I'm going to close this area also. Let's use up to this surface. So this also it's closed. So there's one more sketch at the bottom. So in the reverse direction, I'm going to close up to this surface. So it's closed now. So now let's have a look here. There's one more opening are there, but here we need to be very careful. There are some drafts is there in this. So direct extrude option may not help you to close this. So whereas I'm just going to use loft feature to close this loops. So this area also it's closed. So now let's have a look here. Already I closed this few things, and as I know this, there are some side cores here. I'll just refer this plane to create a side core. So this is the side core area. So I'm just going to convert these entities. Let's extrude this also in this direction. So in the reverse direction. Now you can view the same area will be considered in this. The side core will be created already. So I just did some patchwork. Wherever openings are there, I closed. But if you study this component properly, let's have a look. I'm just going to hide this this solid body which I created just now. And if you view here, there are still some features are there in the component which we are not at all not taken care in the particular solid body. So let's create those things in this. So advantage here is that there are some on direct feature is there in SolidWorks environment to open those features. I'm just going to target this, and then I'm going to cut with these components. Now you can see still the rest of the area from the components. Now it is taken care in this particular solid body. So now everything will be fine. Now let's create a parting surface. I'll just show you how easily you can create a parting surface. This is not a simple parting surface. There are some step parting surface is required to create this. So let's have a look. So I just created one simple sketch here to create a parting surface. So let's use SolidWorks surfaces to create this. So one planar face will be created. But advantage here is we have a direct option to create a parting surface in this environment. Let's use these options. So I'm just using this face and few edges, couple of edges here. So there are some continuous edges. Directly you can create a parting surface. I just use these planes to create this in this direction. So quickly you can see the parting surface is created. So on another direction, once again I'm going to use the same option. So this time I'm going to use another plane to define the direction. So just refer outer edges. So you can see immediately this surface also created. I just have another side. Once again I'm going to use the same option. So this time I'm going to define this direction. So I'm going to refer these edges. So immediately parting surface is created for that. I need to create one more surface. So finally I'm going to create here in this direction. Just there are two edges left here. So this surface is created. So we have direct option here to create a parting surface, even if it is a round component, if it is a solid component. So different kind of approaches are there. For this component, to extract the core and cavity, already we did some patchwork, and then we have covered all the parting surface. But one surface you see here I created by using surface options. Still it is not considered as a parting surface. So here I'm going to define this one also as a parting surface. We have a direct option to define this. So since these are all we used parting surface options, so only one surface is left out. So this surface also I'm going to define a parting surface. And also all the solid bodies which we have created so far, the solid attributes, we can use solid attributes to define this. Let's have a look here. So this is by seeing itself you can define this should be a part of cavity. So let's define this as a cavity patch. Similarly, this as a cavity patch once again. So I'm just going to define a core patch. So there is this part 5 and this part 5. I'm just going to define as a core patch, and then finally I'm going to define this as a side core. So now directly you can create a core and cavity. So far I just completed all the work. Let's create a core and cavity for this. There is one side core in this. So now you can see here there are some cavity and core will be created. So I'm just going to add side core. Side core will be part of this. Similarly, I'm just going to add, you remember I did some patchwork for wherever openings are there for cavity. So these cavity files are going to attach with this. So once again for core files, so core files also going to attach with this. So now we can see exploded view for this. Cavity, core, and then side core you can view. Also you can view the animation part for this component also. So let's concentrate. You can see here there is a cavity part which is already created. So I'm just going to make as a single part file. Similarly, you can view the core file. So there is a core part, and this is taken care all the which you did in component area. The same part file, everything will be created here. So I'm just going to combine this and I'm going to make as a single part file. From here, for mold designer, we need to define whether we need to continue with just one cavity mold or two cavity mold or number of cavities we need to define. There are based on our requirement we have to define a mold design. So for that, it saves a lot of time to designing the mold design. Let's have a look here. By using layout wizard, so directly user can define number of cavities, just mentioning, for example, there's a single cavity, a double cavity, or 4 cavities, or 8 cavities, or number of cavities in this linear direction and multiple direction. Once again, the number of cavities can be defined. If it is round component, yes, you can place the component in circular pattern also. For example, you can view this here, number of cavities you can control here. This layout wizard will help user to control the placement of the component, orientation of the component, direction of the components. Now you can view there are two. I'm just going for 2 cavities. So since the side core area will be here, I'm just going to change the direction, the orientation especially. So now you can see the side core direction will be here. This is also not acceptable. I'm just going to change the direction also. Now it is in the reverse direction. So here we need to control gap between the blocks, gap between the core and cavities. So just straight away we can mention the values here. So already 2 cavities will be created. So now we'll add the mold base. As I told you, already we have a mold base library. There are some standards libraries are available here. So I'm just going to add this. So there are different configurations are available, different sizes are available here. So we can just check suitable size for this assembly. I'm just going to add this, and you can see the preview here. By seeing the preview, let's define, since every time the core and cavity size will be vary. So here itself we can define the sizes of the plate thickness. Let's have a look here. This is going to change immediately. So core dimension I'm going to change here, and then immediately spacer block the heights also you can change. If required, the gap between moving off and fixed off, yes, you can control this by using these options. Maybe just 0.5 gap both the side, and also you can control offset between the rest buttons, between the ejector assembly and bottom plate by providing rest buttons. This gap you can control here. So, and also the direction of the mold you want to place, you can directly view the orientation here to place the mold base to this assembly. So I'm just going to check all the information here. I'm just going to provide these parameters, and I'm going to continue. I'm going to apply with this. Now you can view here, immediately complete mold base will be added to the same assembly. So once again it will pop up whether you want to change or you want to going with the same mold base. So just it will take a time, and immediately it's going to cover complete assembly. So just inserting a mold base into sub-assemblies. So quickly you can view here the mold base will be created. Once again it is going to pop up the same question. So whether you want to change or you want to go with the same mold base. So now you can see the mold base will be ready based on our selection. There are library, there are different sizes are available. Based on our requirement, you can add it quickly. And only a mold base. And now this is actual assembly. You can view there is actual assembly here, which already core and cavity assembly sub-assembly will be inserted. So now again is the concern is as a complete mold design we need to cover many options. I'll just highlight I'll give you brief you few more options here. So we need to take care pocket openings in this. So quickly it's allow user to open these pockets in these plates. I'm just going to target core and cavity plates. So let's target this. So here there is a face and here there is a face. I'm just going to select. Now you can see immediately this pocket opening will be updated in this plate. So let's open this. So pocket opening will be updated in this plate. So if you want relief in the pockets, so again it takes time, but direct options are available to create a pocket corners. Immediately you can create a relief also for this. Just come back to assembly. So easily you can locate whether you want mold base or if you want a sub assembly for just a core and cavity assembly or just a part file or cavity file or the complete working assembly you want to open. So direct options are there to just to speed up your work. So far I just shared a skill mold base, and in my live presentation also I shared the same information to you. Still now it is not a complete mold design. Still there are many things we need to cover. Yeah, as a actual mold design, still many things are there. So this solution also offers you the complete solution. So I'll just continue a few more things like slider wizard. Slider wizards help users to simplify and standardize slide and lifter design.
Yeah.
There are some examples you can view in these slides, so which is already inbuilt in this library. So intelligent slide creation with minimum inputs, user need not to spend more time on this. So allow user to edit all the parameters directly on the screen. So easily release undercuts, adaptable lifters and slide mechanism, etc. You can view the library item in these slides. So similarly, for ejector wizard, Ejector wizard supports the blade ejectors, step ejectors, and ejector sleeves. Quickly, user can search for suitable ejectors in the library. So it's automatically locate all the holes in all the plates once you position the ejector. So user need not worry about the pocket opening. Once you place ejector, it's automatically is going to update all the pocket opening in this. So any changes in your sketch or any changes in the positioning part of it, so immediately this also going to update in entire mold base. So also I would like to highlight few more things like sub inserts also is a part of this. So every core and cavity, maybe few complex area directly is not able to manufacture. There are some ways are there to create a local inserts and sub inserts so that we can make our work easy. So this solution offers you to create a individual inserts also any profile directly on the screen itself you can convert into a local insert or sub inserts. And also cooling wizards create pattern based cooling paths, parametrically constrain their position and connections, and also instantly it subtract from core and cavity if any change in the cooling channels. So basically this also help you to speed up your work. So not much, there are already predefined sketches are there for cooling channels. So directly a user can use these predefined sketches and then quickly he is able to create these cooling channels. In mold design, again, the major role is again the feed system. For feed system, there are different kind of runners and different kind of gates are required. So already in this solution offers you types like full round and half round and trapezoid and U-shape runners, and also it's going to, for gate design like pinpoint gate and slide gate and submarine gate and tunnel gate. So basically these are all just a type and there is a cross section. By using this cross section, so any type of runners you can define. So I'll just brief you this step with the live presentation. So at the end you can see this is not just a mold design. We have an electrode solution for electrodes also. Finally, to manufacture any core and cavity or any things, so we must need to need electrodes also for complex area. So here this by using electrode wizard we can create electrode bodies quickly and easily. Also it helps us to create a holder design. So the moment you define holders, so immediately it will give you the distance between the, suppose if you define origin, if you define a reference point for in the core or cavity any area from the particular reference point, what will be the difference from the x and y origin, and then if it is what is the spark depth, or total depth for sparking this particular complex shapes. I'll just brief you on these things with the live demonstration. So here you can see already I created so far just a core and cavity and then complete mold base, inserted complete mold base. So now I'll just use the product assembly. I just use a slider wizard to create a moving core, finger cam, like guide rails, wear plates. There are a lot of things are there. So advantage here is for user, this is already inbuilt in the library so that he can save his time. Let's use this slider wizard. Now you can view here, I'm just going to concentrate on side core part of it. Let's open this part file. So individual part file will be available here. So already predefined some moving cores or different kind of in the library you can view here in the right side. Different kind of shapes are available. So I'm just going to quickly, I'm going to create this. And you can see the approach also here, it's very easy. I'm just going to click this, immediately this part file will be created in this. So any changes required, still we can modify. This is all with the dimensions on the screen. At the same time you can edit the dimensions. Let's have a look here. I'm just going to change from 60 mm to 40 mm. So immediately this is going to update the moment you rebuild this. So I'm just going to create a finger cam hole on this. So if you have any doubts, also it will help you to how to do this selection for this creation. Let's have just I need this face and this edge to create a finger cam hole. Let's click on this. Immediately you can see finger cam hole will be created on this. So I'll just come back to assembly. So core and cavity blocks are there. So let's hide this for some time. So I'm just going to concentrate on side cores. So side cores, for side cores, just going to add some more component. So guide rails. Guide rails are required for this. So guide rails you can view from the library. There are so many still inbuilt items are there in the library. So I'm just going to create this kind of a guide rail. So for this, I'm just going to select this and let's add this into assembly. This is automatically part of the assembly. So any changes, just for user, for mold designer, it's allow you to just pick and place from the library so that to complete this task. So let's change these dimensions if required. Let's say I'm just going to double click these dimensions. So immediately this is going to update. So since already I have created mold base, so I have all the reference planes for this. So I'm just going to use these reference planes. So there are reference planes you can view here. So I'm just going to add finger cam for that. First, I'm going to select this cylindrical face for this, and I'm going to add from the cavity position. So I'm just going to select this plane. Let's select finger cam for this. Now you can view here directly finger cam will be part of this assembly. Similarly, let's add for locking purpose. We just let's add a wedge block. So we can just quickly add wedge block for this area. I'm just going to select this. So immediately individual part file is created and already assembled in your assembly. The moment you double click this part files, you have all the dimensions, all the parameters, any changes required in the dimension part of it. It's allowed at the same time you can do those changes in the part file. So like this, I'm going to create a wear plate for this. So immediately you can see wear plate will be part of this. It's just like this environment provides you just pick and place from the library and complete your task. So let's have a look. Already I have created everything for this. The complete assembly will be here. So I'm just going to open cavity part to show you how easily you can convert any area into a local insert or sub inserts. So there are in this cavity file you can view here. There are some round pins are there here, and there are some another profile here, which is directly it is difficult. If we create a sub inserts for this, it is easy way to manufacture this part file. So let's have a look for this. I'm just going to finish this, and I'm going to use insert wizard. So I'm just creating the insert wizard. I'm just creating inserts for these round pins. The moment I click this, so immediately it is converted as a separate individual inserts. Similarly, so another insert will be available here. Same way I'm going to convert this also. So immediately this is converted as an insert. Whereas another profile, if you observe here, since there is a draft here, so directly is converting this is not a way actually. But whereas we must need to retain this area in the components. So for that purpose, so I'm just going to use this as a face and so these outer edges to create a sub inserts. So let's create once again. This is the face. I'm just going to select these edges. So basically all the outer edges. So now you can see immediately this insert also, this area also converted as a individual inserts. So now I'm going to show how easily you can create a holders for this. So there are round type and rectangular type holders are there. So based on the profile you can define, user can define here. So I'm just going to create a holder for this. So dimension part you can control here. Immediately holder will be created for this. Similarly for rectangular insert, I'm just going to change this shape. So now you can see the preview here, and dimension part you can control for this also in all direction. Suppose if you want to shift just to just one position, and now you can view here. You can change the center position also for this. Just one side color we required. You can make it just one side color for this. So immediately this holder also created for this. So this solution offers you quickly, you are able to convert sub inserts from the core and cavity part files. So let's have a look for this. I'm just going to hide this part file. There are three separate inserts are created from the geometry. So the moment I hide this one, you can see that the same pocket opening will be available in your cavity file. So let's have a look briefly about cooling channels. I'm just going to finish this insert wizard. As I told you earlier, for cooling channels already predefined sketches are there, but we can use predefined sketches, or else even we can directly create some sketches to define a cooling channels. So there are already sketches are there. I just use that to create, and direct parameters are there to add cooling channels, and different type of holes are available here. Let's have a look this one. The moment I click this one, the same shape will be available here. So I'm just going to add this one here, and then I'm just going to select all the lines, cooling channels. So quickly user can easily able to add all the cooling channels. So immediately it is going to subtract holes in the particular part file. So now you can view all the holes are available here. Still any changes are required. I'm just going to convert into wireframe mode. Now you can view this properly. So still any changes required, with a better we'll create this sketch with a dimension to constrain fully. So here still we can change all the dimension, and we can modify according to our component area. So this is going to update immediately. And the same way there are some accessories also there, like still we want to plug in, you want to define inlet and outlet. For example, let's say this is the area I'm going to end plug. So immediately this is created here. Similarly, if you have some accessories like the O-rings we want to use, the O-rings will be created here. So I'm just briefing you how easily you can create a cooling channels, how easily you can create sub inserts in the cavity file. Let's come back to assembly here. I'll just quickly show you how easily we can add ejector assembly for the component. To add ejectors from the component, just we need a sketch for this. So I'm just defining the position for ejectors. So this position selected by the users or mold designers. For example, I'm just selecting this is the location. So one more I'm going to locate here. Similarly, few more I'm going to add here by using a linear pattern. So a few more points I'm going to just add to show you. I'm just going to add in irregular areas also. So let's finish this one in part file. Let's move to assembly file. So already this sketch will be updated in assembly. So you can view here already this sketch is available here. So now I'm just going to locate ejectors. Since already we have a library for the ejectors, so this is the positioning I'm going to make. So here there is a dimension part. So let's take more only at present. I'm just going to create the height will be more than the core. Still we have some more option to match properly with the core sheet. And any changes in the component area. So sometimes we need to lock properly these ejector pins. We need some chamfer in the collar. So directly options are available to define single cut or double cut. For example, I'm just going to use single cut for this. Now you can see immediately all individual, the way I selected from the library, same files will be, files are going to add one by one in this assembly. So I'll just show you how it's created. Let's see here, just have a look. There are some inserts are there. I'm just going to hide the component also. So let's match these ejector pins with the core sheet. We continue with this. You can see the ejector wizard here. This menu itself will guide mold designer or users to follow the procedure. I just did the positioning and I have selected from the library. So any changes required, even though you add this ejector pins, still it's allow you to modify or do a changes in ejector pins dimensions or parameters. And then now finally you can use these options to match with the core sheet. Let's I'm going to select all the ejectors. Now you can view here, this is going to match properly with the core sheet. So it's going to match properly here. Similarly, even if it is irregular areas also, this is going to match properly here. Like some more pockets of opening in the block itself we want. So I'm just going to create the same pocket opening we need in this block also. So let's once again select all the ejectors. Immediately this pocket opening will be updated in these blocks. Now you can use, there is some relief here. From here this guiding is going to start. So let's come back to assembly. So whatever I have done so far for the one cavity. So now you can view here. I just completed slider wizard, moving core, guide rails, finger cams, and then ejector assembly, like inserts, creations, or cooling channels for one cavity. Whereas the rest of the cavities updates automatically. Just imagine If it is a 10 cavity mold or 20 cavity mold, is a number of cavities, how much time user can save to create all these things? So just the user need to, mold designer need to work for one cavity, rest of the cavity will be updated automatically at the same time. So quickly, I'm just going to share. So far, I shared. Similarly, we have a feed system to create, and as I told you, electrodes also. The time not permit to show everything in detail, but let's have a look. We have a solution for feed system as well electrodes also. Just going to show some more slides in this. Like I just shown one of the complete two-plate mold design, whereas still it supports even if it's a family mold, if it's a different component we want in the same mold, still it supports a family mold. Similarly, if it is a typical three-plate molds will be required, so also it is going to support three-plate molds. So just you can view here. So now if you have any questions, let me know. So just I'm going next 10 minutes is just allowing you to let me know any questions so that we'll clarify the same now. So thank you very much for joining this session. So just let me know any questions. So basically, I just shared this is just a brief introduction about the workflow in a 3D QuickMold environment. Feel free to call any doubts. The contact details will be there. So I can see there is a question here. Can I have a copy of this to my email? So definitely once the session will be over, definitely we'll get back to you soon by email. Our team will be in touch with you. So I can see one more question here of whether we can analyze material flow. I would like to tell you here this solution basically for mold design. Yes, you can analyze material flow also. For that we have in SolidWorks a Plastic Professional and SolidWorks Plastic Premium, which is going to cover complete complete mold flow simulation and as well as flow simulation, packing simulation, everything. So still there is another add-ins will be available. So there is a question here. I can I can see here from the audience. Can we able to create hard runner molds design? Yes. In this presentation, I shared the two-plate mold and then with the cold runner. Of course, yes. If you just switch to screen, if you view here the library, in the library, You can see that already there are in the library everything will be available like DME standard, Hasco standard, and then heart runner. In the heart runner, you can see all types of different type of manifolds. I hope you can see these manifolds here. So different kind of manifolds and nozzles or pressure pads. So already which is inbuilt in the library. Instead of cold runner, we can use hot runner. We can use for hot runner molds also by using this library. So feel free to ask for any doubts if you have. For hot runner mold, if required, we'll get back to you soon, and we'll arrange one more demo only for you to showcase more, highlight more on this system. As soon as possible, we'll try to arrange one more demo for you.